Hi, welcome back to my channel. Continue 2.2 atmospheric pressure. We'll discuss on problem solving and also effects of atmospheric pressure at high altitude and effects of pressure at extreme depth under the surface of the sea. Let's look at some example on this problem solving part. Example 1. The blood pressure reading of a patient is 160 over 100. What is the pressure? 160 millimeter mercury in Pascal, meaning we need to change the unit from millimeter mercury to SI unit Pascal. Given here, density of mercury rho 1.36 times 10 to the power 4 kilogram meter to the power negative 3, and gravitational acceleration g equals to 9.81 meter second to the power negative 2. How we solve this question? First, the formula that we are going to use actually is P equals to H rho G. So you can list down all the information given. For example, what is H? So in this situation or in this question, H equals to 160 millimeter based on the value of pressure here. So H equals to 160 millimeter. You can convert to SI unit. So 0.16 meter. Gravitational acceleration g equals 9.81 meter second to the power negative 2. Density of mercury rho equals 1.36 times 10 to the power 4 kilogram meter to the power negative 3. Now we can substitute all the values given here. H equals to 0.16 meter. Density of mercury and value of G. Thus we get 2.13 times 10 to the power 4 Pascal. So you can leave the final answer in standard form, or you can write in terms of kilopascal. So for this one it will become 21.3 kilopascal. So this is how we convert the unit. Given, for example, in millimeter mercury, we can use formula H rho G, so that you can convert to Pascal or SI unit. Example 2, the maximum pressure that a wall at the seaside can withstand is 3.6 times 10 to the power 5 Pascal. What is this maximum pressure in meter of water? So you can see from the unit of Pascal, now we want to convert to meter of water. So this is a metric unit. So given here, density of water rho is 1000 kilogram meter to the power negative 3. G 9.81 meter second to the power negative 2. So the maximum pressure 3.6 times 10 to the power 5 Pascal. Density rho equals to 1000 kg meter to the power negative 3, and G is 9.81 meter second negative 2. So we use the formula P equals to H rho G. Thus we get H equals to P divided by rho G. The value of P is given, so you just substitute here, divide by density of water, divide by G. Thus we get 36.7 meter. Because of this height refers to water, then the pressure can be stated in the unit of meter of water as 36.7 meter of water. Okay, so this is another unit that can be used to show the values of pressure, or to write atmospheric pressure. Okay, second part I want to discuss on effects of atmospheric pressure at high altitude, meaning high places like on the top of mountain, and effects of pressure at extreme depth under the surface of the sea. Let's look at the first part, at higher altitude. Thin of air causes atmospheric pressure to become lower, meaning at higher places the atmospheric pressure is smaller. The percentage of oxygen in the air reduces effects on human beings at high altitude. So we will experience lack of oxygen at a very high place, such as Mount Everest, very high altitude. So this one will increase in the rate of breathing. Lower absorption of oxygen in the lungs, increase in metabolic rate, loss of appetite, dehydration, inability of think clearly. So this is effect of smaller atmospheric pressure at higher altitude. So adaptations and action to be taken. What are the preparation needed? For example, for mountain climbers, prepare and train before climbing. Prepare equipment such as smartwatch that can measure altitude, blood pressure and body temperature. Climb at a slow rate to allow body to adjust to the changes in pressure. Drink water even when not thirsty to prevent dehydration. For the aircraft, meaning higher altitude also, increase the pressure in the aircraft cabin to match the sea level pressure. Recycle the air in the cabin so that it is fresh and contains adequate oxygen level. Remind the passengers to drink enough water to prevent dehydration during long distance flight. So you can read more about this one. How about the pressure at the extreme depth under the surface of the sea? At extreme depth under the surface of the sea, water pressure increases with its depth. If you still remember the relationship, pressure is directly proportional to depth. An increase in depth of 10 meters causes an increase in water pressure by 1 atmosphere. 10 meter water, so the pressure is equal to 10 meter water. Water pressure and atmospheric pressure are experienced effect on human being at extreme depth under the surface of the sea. Body tissues absorb excess nitrogen gas. Nitrogen gas dissolves into the blood. Inability to think clearly. Formation of nitrogen bubbles in the tissues or blood vessels if pressure is reduced too rapidly. The adaptation and action to be taken, for example for divers, do physical exercises to enable body to adapt to high pressure environment before diving. Wear a diving suit to slow down heat loss from the body. Slowly ascend to the sea level so that nitrogen bubbles do not form in the tissues and blood vessels. So there's a limited time given for divers. So after that time given, they must ascend to the sea level so that the nitrogen bubbles do not form in the tissues. Submarine. Submarine is made of steel or titanium with a circular cross-section to withstand high pressure surroundings. Pressure in the cabin of submarine is controlled to almost same level as the sea level for comfort of the crew. Oxygen tanks or electrolytic oxygen generators are provided so that oxygen supply is adequate. Okay, so these are the actions that need to be taken for the safety for divers. Okay. So I think I will stop here so you can read more about this one. You can also find a lot of the pictures regarding this situation, pressure at extreme depth of the sea and also pressure at higher altitude. So it is very interesting. Okay, that's all. Bye.